All right. Here we're going to write the equation of a line just from its intercepts, its x and y intercepts. And I'll show you two different ways to do this. All right, one. I could use point slope form to do it. So the slope here, our change in y, is going to be so I know the two pairs of coordinates. We're pretending we don't have the graph here, right? So our change in y, just going from one point to the next, would be, if I call this point A and this point B, and going from A to B, remember it's end minus start equals change, and we'll pretend we're going in this direction. Then it's 0 minus 4 equals negative 4, and our change in x, end minus start equals change. So 3 minus 0 equals 3. So our slope, change in y over change in x, would be negative 4/3. And we could pick either one of our lines, or either one of our points, I'm sorry. So y equals m x minus h plus k, where m is the slope and hk is any point on the line we choose. We can choose either one. So y equals our slope, which is negative 4/3. X minus, let's pick this point down here, 3, and plus 0 for our y. And there we go. That's our equation. Okay. Now, we could also, if we wanted to, we could write this out in standard form using the intercepts. It will look like this. So I've got ax plus by equals c. And as we've seen before, we can actually use lots of different values for c. And whatever we choose for c will kind of determine what our a and our b are over here. So I could just arbitrarily choose 1 for c if I wanted to. I could say ax plus by equals 1. Now if I were to figure out what these intercepts are, I would just plug in, if I sort of say I knew the equation, I was trying to find the intercepts, I would plug in a 0 for x, and that would just eliminate the x term, and then I would solve for y. Or I would plug in a 0 for y, and that would just kind of eliminate the y term, and I would solve for x. So what we're going to do here is we're going to pretend as though we've kind of already done that, right? Hold on a second. All right, so let's do this ordered pair here. So I'll do a times 0 plus, I'll plug in 4 for y here, b times 4 equals 1, and this term just kind of goes away, and b times 4 equals 1 divided by 4 on each side, and I get that b equals 1/4. Okay? I can do the same thing over here. Ax plus by equals 1, and this time I'm going to plug in the other pair, so it's 3, 0. So a times 3 plus b times 0 equals 1, and that's just going to eliminate that term. I'll divide both sides by 3 to get a equals 1/3. So basically, I plug in the points and I solve for the coefficients. You're kind of working in reverse there. And I end up with 1/3, so a was 1/3, x plus b was 1/4, 1/4 y equals 1. I could scale this up. I could multiply it. See, if I multiply everything times 12, and that's going to eliminate both of our fractions here, I would end up with 4x plus 3y equals 12, if I wanted to. So there's another form of the equation. And let's just show that these two methods kind of give us the same equation in the end. So I'm going to take this one here. Let's kind of open this up, parentheses up here, and I get y equals, let's see, negative 4/3 x. See, this is plus 4. And of course, the 0 there doesn't change anything. So there's our equation. Okay. In slope-intercept form, let's change this one into slope-intercept form. So let's see, it would be, I'll copy it down here, 4x plus 3y equals 12. See how 3y equals negative 4x plus 12. Divide everything by 3, and I get y equals negative 4/3 x plus 12 divided by 3 is 4. Right? So if I turn either of these equations into slope-intercept form, I get the same equation. So again, what methods were: 1, use point-slope form, so you can calculate the change in x and change in y, and therefore the slope. Right? Find slope, okay, using the 2 points, and then we can use that point-slope form to find the equation. Find equation, right? So that's one method. The other method is to write the equation out in standard form and just choose some number, whatever you want, for C. I just chose 1, partly because of a problem you need to work on where C is 1. And then you just plug in the coordinates and solve for the coefficients. So I have ax plus by equals 1. If I plug in the coordinates 0, 4, for example, it eliminates half the equation, and I can easily solve for the other coefficient. And then when I plug in 3, 0 over here, so you're plugging in for x and y, you're plugging in the coordinates x and y. So 3, 0 I plugged in over here, and over here is 0, 4. And because they're intercepts, they have zeros in them, and that just eliminates one of the coefficients very easily, and I can solve for the other one. I got b is 1/4, a is 1/3. Put those back into the equation, ax plus by equals 1, and I have my standard form equation. Because I suppose, really I want kind of whole number coefficients here, I suppose. But and either way works. You'll end up with different looking equations, but they should be the same. And if you want to check to make sure that they're the same, you could take either of them and change them into slope-intercept form, and you should get the same equation either time. All right? And that's how to write the equation of a line using 2 different methods from just the intercepts of the line, the x and y intercepts.